Welcome to lecture number 96 of Digital Electronics. In this lecture, we are going to deal with clock skew and time rise in flip-flops. So coming into the first topic, that is clock skew. So what is meant by clock skew? Now, see, generally, if you are having a sequential circuit, so I have already mentioned in the introduction of this module that we are having sequential circuits, and that too is classified into synchronous sequential circuits and asynchronous sequential circuits. Okay. Now, in the case, for example, if I am considering asynchronous sequential circuit, say T flip-flop, okay, I am having Q and Q bar. Okay. In asynchronous sequence circuits, generally clock will be connected to the first one, and the output may be having it will be connected like this, say Q and Q bar here. It may have some logic gates, and this will be connected to the clock of next T. Okay. So here what happens is that, see, once I am applying the clock, okay, the clock to the, say this is flip-flop number 1 and this is flip-flop number 2. Okay. Now, here the clock of flip-flop number 2, here what clock of flip-flop number 2 will be triggered only after a time delay. That time delay is caused due to delay of flip-flop number 1 and flip-flop number 2. So what happens? The output of the flip-flop number 2 will get triggered after a long time delay. Now one question. Say I am having a time delay of 10 seconds in all together. I am having a long time delay of 10 seconds altogether. What will be the output in that 10 seconds? Okay, so I am having 10 seconds. So after the 10 seconds, all the output will be okay. I am giving an example. Okay, 10 seconds it is a bit large value. Now, what is the value of output? What is the value of output of flip-flop number 2 from 0 seconds to 10 seconds? Okay, that is my question. So here what happens is that the clock of the flip-flop number 2 is not received. It will be received only after 10 seconds. So in that time period of 0 to 10 seconds, the output of flip-flop number 2 is unpredictable. Okay. So that is regarding this asynchronous circuit. Okay. Now coming into this synchronous circuit. Synchronous sequence circuit. Synchronous sequential circuit. Here what happens? The specialty of synchronous sequence circuit is that clock is common. Clock is common to all the flip-flops which is connected. So, for example, if I am having same T flip-flop itself, Q bar, another T flip-flop, so that is flip-flop number 1, flip-flop number 2, okay, with T, Q bar. So this is T1, T2, and here we are having a clock. Okay, I am keeping the clock as common. Okay. Another flip-flop T3. Again, the clock is kept common. Okay. This Q and Q bar. This is flip-flop number 3. But in this case, what is the issue? There is an interconnection. Here there is an interconnection. Here there is an interconnection. Okay. Now, when the clock signal is applied here, there will be a time delay due to the time delay produced by this interconnection. There will be a time delay produced by this interconnection. That is, here what happens is that interconnection or this wiring or the time delay is caused due to this wiring. Now, that means here what I mean to say is that this clock will be received by flip-flop number 1 and flip-flop number 2 and flip-flop number 3 at different time instants. Clock will be received by flip-flop number 1, 2 and 3 at different time intervals or time instants. So for example, at 0 seconds flip-flop number 1 will receive, and according to with the time delay, this will receive after say 2 seconds. For example, okay, this may receive after 3 seconds. Okay, that delay is known as clock skew. That delay is known as clock skew. So clock skew is better to explain in synchronous sequence circuit. Okay. Whereas in a synchronous sequence circuit, what happens is that it may go to the unpredictable state. Whereas in a synchronous sequence circuit, there is no question of going into the unpredictable state. But only here what you need to remember is that the clock will be connected to all the flip-flops. That clock is in common. And here that delay is caused to the wiring between the clocks of these flip-flops. Okay. That is, the clock may reach. Maybe it can reach in the same time or in different time. Now, if the clock is reaching in different times to different flip-flops, what happens? Then it will produce output at the proper output will be produced after all the flip-flops are receiving clock. The proper output will be produced only after all the flip-flops have received the clocks. But in that, there is a time delay. That time delay is known as clock skew. Okay. So that is regarding this clock skew. Now coming into the second one. That is time race. Now, generally, in all synchronous sequence circuits, in all types of synchronous sequential circuits, clock skew it should be minimum. Okay. Otherwise, what happens is that if clock skew is maximum, there is a chance that one of the flip-flop may or may not respond. Okay. So clock skew should be kept minimum. In that case, if clock pulse is delayed, then there is a chance that if inputs are changed, before the clock arrives, before the clock arrives, before the clock arrives. That is a special case. That is, I am having a, for example, I am having a T flip-flop. There is a clock. Okay, this is remaining as 1. So I am having like this. Okay, and there is a delay in the clock. So I will draw T here, like this. But clock is already arriving only after a certain time delay. Okay, this is basically the clock. So there will be a time delay of the clock. This is the clock, and this is the variation of T. So in this time delay period, what happens? That is the question. In this time delay period, what happens? So how to account for it? Here what happens is that T has changed the value from 0 to 1, and the clock signal has not arrived. Clock signal has not arrived during this time delay period. That is the issue. So here what happens is that when T is coming in, as 1, and since clock pulse is not received, what happens? Q will remain as 0. Okay. Whereas at the instant when clock pulse is received, the value of Q will be changed to 1. Okay. Otherwise, what happens? When the clock is remaining as 0, Q will try to remain in 0. Okay. Or in another track, what we can say is that suppose the initial condition of Q is 0. Suppose the present state of the Q is 0, and when T is equal to 1, it should go to 1. That is, next state is 1. So here what happens? T has become 1. And I have not applied the clock. So there is a tendency of Q to change from 0 to 1. Okay. And since clock is not there, it will remain as 0. That is one thing. Now, at the instant when clock arrives, what happens? Then only the value will be changed from 0 to 1. The value of Q will be changed to 0 to 1. Okay. But when the clock is 0, what is the drawback of that? When a clock is 0, what happens? When a clock is 0 and T is equal to 1, Q will try to change from 0 to 1. Q will try to change from 0 to 1. But since clock is equal to 0, what happens? It will come back to 0 again. That means by adding the clock and without the clock, or when clock is equal to 1 and clock is equal to 0, it is exactly the reverse effect. Okay. So once more I am explaining that when I am having the clock, when clock is equal to 0, and there is a propagation delay there is a delay time of the clock. Now at the instant when T value arrives, let the present state of Q be 0. It will be changed to 1 in the next state, provided T is equal to 1 and clock is equal to 1. Now here what happens? There will be a time delay in the clock. So when the T arrives, what is the value of the clock? When T is equal to, in that time delay, value of T is equal to 1 and value of clock that is equal to 0. Now due to this T, what happens to Q? Q will try to change from 0 to 1. And since clock is equal to 0, what happens? The Q should be maintained in 0. That is the first part. Second part, when T is equal to 1 and at the instant when clock is changed to 1, that 0 will be changed to, the value of Q will be changed from 0 to 1. But initially there is a problem. What is it? When t is equal to 1, there is a chance from changing from 0 to 1. There is a chance from changing from 0 to 1. And it is remaining at 0. When clock is equal to 1, it will change 0 to 1. So what happens? It is basically ulta effect, or it is basically the opposite effect. Okay, that opposite effect is due to this time delay. That effect is basically known as time race. So whichever comes first, it will take action. Right? If t is equal to 1, it will take immediate action. That is, q becomes 1. But since clock is 0, it will come back to 0. That is one action. Whereas when the clock comes and t is equal to 1, it will take the value of q will be changed from 0 to 1. Okay. So that two are opposite effects. So that time race is due to the time delay of the clock. Okay. So hope you have understood what is the concept of this time race. Okay. So in this lecture I have dealt with what is meant by clock skew. So clock skew is generally happening in synchronous sequence circuits, and second one is time race. Time race is the ulta effect when coming into picture when there is a time delay in the clock. Okay. Thank you. And in the next lecture we will be dealing with what is the potential timing problem and maybe race run condition in flip-flops. Thank you.